All right. So just in the interest of time, let's go ahead and kick this off, and we'll also be recording it and sharing the link out, so you'll be able to watch. So I just wanted to thank, let me kick the recording off. There we go. So I just wanted to thank everyone for joining us today to talk about challenges with geospatial data. One quick housekeeping note, if you have any questions as the presentation goes on, feel free to type them in the chat box and we'll be sure to address them at the end of the presentation. I promise it won't be a death by PowerPoint, just a couple in the beginning to get us kicked off. So my name's Chad, I'm an account executive with OneSpatial, and with me is Melissa, who's our solutions engineer. She'll be walking us through the demonstration of OneIntegrate in a few minutes. So I just want to start off with a quick background on who we aim to be. OneSpatial was founded 50 years ago in Cambridge, UK, and focused on data management and working very closely with our customers on very large and complex data sets. Our group here in the US is a wholly owned subsidiary of OneSpatial Group, and we work with a variety of customers at the federal, state, and local levels, as well as many other industries. Next slide, please, Melissa. So one case I'd like to kick off this presentation is our work with our first customer in the US, the US Census and the Map Tiger Conflation Project. They're receiving data from over 3,200 providers. Each of those data submissions can be in different formats, standards, and schemas. So we worked with them to create an end-to-end solution to bring that data in, run through our OneIntegrate engine to validate the data, map the schema into the required census schema, and run change detection on that data. There are two actions for changes that we find in the data. For the changes that fall within census's threshold, we automatically update and integrate that data into the data. For any that are outside those thresholds, we create what we call proposals for manual review by an analyst. Any of those proposals that are accepted by the analyst will go back into the automated process while others will be handled manually. From there, the data sets are updated and project rolls on. This at one point was a very manual process, reviewing the data, which also introduced a good amount of subjectivity to the corrections being made. We're proud to say that we have heard this process is over 90% automated since leveraging the OneIntegrate solution, and hope to be in the very high 90s by the end of the year. Next slide, please. So here are many of our other customers span the state, federal, and local governments that have come on since Census. Some of our projects with these customers are supporting them with our rule-based approach to conflate, validate, and integrate their data. This data could be focused on addresses, next-gen 911, transportation data, utilities, as well as a whole spatial data infrastructure project. A couple to highlight are Caltrans, which recently came on board, Michigan, where we are working on a full spatial data infrastructure project, and with LA County, where we're supporting them with some work around addressing. One other customer I'd like to point out on this slide is Google. I like to highlight this just to show that while we're talking about geospatial data today, we are truly data agnostic. The OneIntegrate rules engine can be configured to work with any kind of data out there. So with that, I'd like to hand it over to Melissa.
Thank you, Chad. Okay, so here at OneSpatial, I want to start off with the three aspects that we have for having the spatial advantages for managing data. We're looking at data validation, data integration, and data enhancement. So what is OneIntegrate? OneIntegrate is an automated rules-based engine that lets you define your data quality standards through data validation. So it allows you to build out your business rules, configure them to your liking, and then automate the process of validating how your data conforms to those rules. So as with any process automation, the benefit here is in dramatically reducing that time-consuming process. And not to mention, like Chad mentioned earlier, the subjectivity that's inherently involved when it comes to quality assurance and control measures. OneIntegrate can also integrate your data by allowing you to connect across the entire enterprise into a variety of spatial and non-spatial data. The engine is highly configurable, so you can write a rule that's suited to validate multiple and separate enterprise systems, so you can get a more consistent and improved result out of it. So two road network data sets, for example, which I'm going to show you later on, We can bring those two data sets into one integrate because one integrate is capable of reading both of them into its cache. And then we're also able to validate that these two data sets are synchronized and they actually meet the same quality standard by running them against the same set of business rules. So even if the case may be that these geospatial systems are not necessarily obtained using the same methodology and schema, you can use one integrate to standardize them, which you'll see a little more of in a bit. So if you're in a point where you report your quality issues in your data through data validation, you optionally leveraged the data's quality by integrating another data set with it, the next incentive step would be to enhance your data. One integrate actually gives you the flexibility to automate how you want your quality issues fixed, including creating new data, because the ultimate goal, of course, here is to get your data to the highest quality possible. All right. So for my first use case that I'm going to tackle here, I'm going to show you how we went about a small proof of concept that we did for the state of Indiana. So the sample data we received from them, which is our input data over here to the left, consists of our address points, our road center lines, our county boundaries, and our parcel polygons. To further leverage our interfeature validation checks, I went ahead and added our building footprint data set in there as well. So much like what everyone in the transportation community is trying to do, the state of Indiana was interested in getting a better idea of their current data's readiness as far as migrating it to meet ANINA standards goes. So how will the quality of the current data actually hold up against the Next Gen 911 requirements? So in anticipation of this need for entities such as Indiana State to prepare for their NG 911 push, we had built an NG 911 rule pack that was specifically configured for the NINA standard data model. So in order for us to run these 911 validation rules against our data, the first step here is standardizing the input data schema. So we're going to map our address point data to our site structure address point schema, our center lines to our road center lines, and our county to our county. And then with that standardized schema, we're going to go and run a series of validation rules that range from simple geometry checks, such as checking that the geometry is not null, simple attribute checks, such as checking that a road has a name, to more complex inner feature checks, such as checking that an address point must have the same property address as the parcel that contains it. And then we have some 911 validation rules for road addresses here as well, such as checking that road address ranges do not overlap. So let's take a look at the sample data that we'll be feeding into the engine. So here I have all the counties of the state of Indiana. So for this demo, I just want to focus specifically on one county here, which is Gibson County. We have our road center line data here, our site address point data, building footprints, and our parcels. I'm just going to zoom in a little bit there so we can get a better view. There we go. And with that, I'm going to go ahead and jump into our One Integrate Enterprise interface. So again, this is the rules engine where we configure our business rules, report out the quality issues from the features that fail those rules, and then also go about automating how we want those issues fixed. And I currently have it up on my Sessions tab here. So what is a session? A session is a sequence of processing tasks that make up a workflow on one integrate. So you'll always have to start with connecting to your input data using these open data tasks here, which point to our input data's data store. So a data store is an external source of data. So one integrate is data agnostic, as Chad had mentioned, in that it supports a variety of data formats and allows you to connect to multiple data sources at a time. So I think the ones that we're most familiar over here in the are the geographic database file formats, particularly our Esri file geodatabase and our Esri shape. We're also seeing a mix of supportive native data types here, such as Oracle. And also notice how it supports data types that do not necessarily have any geographic or spatial component to them. So then once your data is uploaded, we gain access to all the contained features within that within the data store, as well as all of their schema tables. And this ensures the compatibility between our data and any of the validation rules that we write. So again, a rule is what we use to define our data's quality standard. So if you find features that fail our rules, we're going to create actions to automate how we want these issues fixed. So we've already connected to the two separate data sources here. Again, we have that sample data from Indiana, about 45,000 features, and I brought in some of my building footprints as well, about 20,000. So I'm just going to look over our validation tasks here. So once we standardize our schema based on a NINA standard model, we're going to push that data through a series of validation rules. And the first set of rules here is our standard out-of-box rule sets that we call the essential geometry checks. These essential geometry checks, they're meant to find the geometric dirt that we typically see in digitization and data collection. OneInnovate lets us define generic rules against all features. So I actually didn't have to write a separate version of these rules to fit all of the feature classes in our input data. Let's have a look at one of the rules that had just finished running. Check for kickbacks. So this generic rule ran through approximately 64,000 objects or features. We found 23 of them with kickbacks in their geometry, and that brings our rule conformance rate at 99.96%. It's a good percentage, but the goal, of course, is to have 100% of their data cleared of these kickbacks. So we're seeing how OneInnovate has already finished a lot of these tasks. It's almost finished running. And the reason why it's that fast is because OneInnovate's engine has a spatially optimized object-oriented disk cache. So the advantage of this is that since every feature that gets read into the cache is automatically indexed, the high performance here is scalable even as the complexity of our rules increase. Let's go back to some of the checks that, some other checks that we have in here. Whoop. So our road geometry checks. So these are just additional geometry checks related to how we expect our road network's quality to be. It includes the connectivity of our road network, for example. And we also have a simple attribute check here, just checking that all of our roads have names. For address point checks, we configured a set of inter-feature checks in here. So in a single rule, we're able to make spatial and non-spatial comparisons across address points, buildings, as well as parcels. And we're also running some 911 validation rules on our road address ranges. And again, another example for that is we're checking if our address ranges overlap. So we are almost done running our 18 validation rules against all of our uploaded features, approximately 65,000, and we're about to finish this in just under 2 minutes. I'll just let it roll for a couple seconds. There we go. Okay, so now that we're seeing a lot of these are actually not 100%, so I'm going to do is look over some of the non-conformances that we found in this data. Let me turn on my markups. Okay, so using our essential geometry check, where we're basically saying that my geometry can be the same as another geometry if we belong to the same feature class, we were able to find these duplicate roads right here. I'm just going to select it real quick. So we have these two center lines that have the exact same geometry. Also able to identify spikes and kickbacks in our data as well. And we're seeing that OneInnovate was actually able to pinpoint exactly where a spike on geometry occurs, which in this case was on a parcel. So for those of you who are editors and GIS analysts that have to deal with this type of microscopic errors daily, I know that you guys would appreciate this because I used to be on a production team that updated digital nautical charts. So back then, the only available validation tool that we had would throw a generic error that says, you know, this coastline has a spike. So really, there was no other way to resolve that error other than to pan through miles and miles of coastline, which is such a mind-numbing task. And all you needed to do to get through that error was to find a single vertex. So that definitely helps out on that editor level. And I know that our partners at NOAA definitely share the same sentiment. In a similar manner, we found kickbacks in our geometry as well. So road overshoots and undershoots, these are also some common geometry issues that we see in the road network connectivity. So here we found this road right here that's essentially floating. Let me zoom in real quick in here. I'm seeing that this road right here got flagged as a non-conformance because it's overshooting, and this one got flagged because it's undershooting. Okay. So we also found a linear containment between two roads here. This segment of Ackerman Road completely contains another shorter segment of Ackerman Road. That is a nonconformance to that rule. Let's move on to some of our attribute check results. So here's a simple one. This address point right here got flagged as invalid. And that's because the check says that address numbers have to be a whole number for our site address points per the NINA standard. So this address point right here, even if it does match your parcel, it contains, its address number is 1005 and a half. So per the NINA standard, again, that's not a whole number, so it got flagged as a nonconformance. Okay, so for this one, we have two intersecting roads of the same name with the same address ranges. So we're seeing an overlap right here. Same name, West 800 South, West 800 South, but you're also going to see at the bottom here with their schema, they share the exact same address ranges. So that is a nonconformance to that rule. I want to turn off my parcels for this one. So in this nonconformance here, our check says that the to value has to be greater than the from value regarding the address ranges. So let me just select these guys real quickly. So I'm seeing that this road is actually digitized to the south. I mean, sometimes there are exceptions to this rule, but we're seeing here that this upper segment of East State Road 165 starts from 7001 to 7499. The middle segment here goes from 7501 to 1938, and the next one rolls on to 7941 to 7999. So even if it might not be the case that the from doesn't necessarily have to be less than the to, we're seeing an inconsistent pattern here between these roads. It's all the same name. And I also want to look at one of these other checks here. So our next check, for this rule, I'm saying that a road should have at least one address point with an address number that falls within its address range value. So if I turn on my labels for my center lines, oh, sorry about that. Nope. All right. So it's East Morton Street right here in the middle that's getting flagged with that nonconformance. Within my map view, I'm only seeing two East Morton Street side address points here. I have one for 416. I have one for 231, but I don't have a site address point that's within 301 to 339. So this it's not incorrect, but we can see how this check can actually be configured to check very similar relationships between address points and roads. So we also ran checks for parcel gap and overlap discovery. So one integrate, let me turn my parcels back on, was able to find these parcels right here that are overlapping. And I just want to I'm going to zoom out a little bit just to give us a better perspective of how invisible this overlap is. So we were able to report a point in that overlap area right there. We were also able to find our sliver right here reported a point in that sliver gap. So now let's have a look at nonconformances to even more of our inner feature checks, actually. I'm going to go ahead and turn this off. It's a little distracting. So we have this parcel right here that got flagged that says it contains multiple address points. So we do just expect a one-on-one relationship between our parcels and our address points. So this parcel here got flagged because it does have two site address points in it, even if it looks like it's designated for just one address, which is 2242. So we also have here an address point that is contained within a parcel. Oh, sorry, but my rule says that an address point that's contained within a parcel must have the same property address as that. So what we're seeing here is we have 7836 South Willowbrook Court for the address point, but our parcel is at 7808. So that is a nonconformance right there. We also found scenarios where where the address numbers were the same, but there's a slight difference in our street name. So we're seeing here 7874 South Willowbrook Court, 7874 South Willow Space Brook Court. And there's a variety of ways in which we can definitely reconfigure this rule to allow close similarities like this to be considered a match. And I can show you how we can tackle that later on in our demo. Let's go to one more in nonconformance here. So all this rule is saying that I have to have my site address point contained within exactly one building. So we're seeing this site address point is outside of my building, this address point as well. Okay, so now that we've seen some of the nonconformances, we're going to try to automate how we want to fix these nonconformances. I'm going to kick this off right here. So what we're going to do here is remove the spikes, the kickbacks and the spikes that take care, that will smooth out our geometries. We're also going to take care of some of the duplicates we found by deleting them. I have a build topology process down here. What that will do is snap the road ends where they overshoot and undershoot. We're also going to move our address points to our buildings. So let's say if I'm an address point and there's a building within 20 feet of me, I'm going to say relocate me inside of that building. If there's not a building that's close to me, but there's exactly one that's in the same parcel as me, then go ahead and assume that that's my designated building. So I also ran some, I'm rerunning some rules here as well, just so we can compare the before and after these enhancement actions that we've automatically run through OneIntegrate. I just went through that pretty quickly. We can actually go back to that and start showing you some of the improvements in our data. Okay. I'm going to go ahead and turn on this conflated issues here. Oh, sorry. Okay, so here we've seen that we got rid of our kickback. So you can see the markups are now floating. Our spike as well, we were able to smooth that out. And part of the alignment process, I believe I forgot to mention, was also aligning our parcel edges to each other. So we have these, we were able to close out this overlap between these two, or line them up. Parcel gaps as well. And what actually, I failed to show this to you earlier, I want to show you that what OneIntegrate was able to do during the spikes and this parcel overlap and gap discovery, we were able to differentiate a gap that looks like a valid gap as opposed to valid easements such as these. So this sliver right here got flagged as a gap. When we went ahead and aligned our data, we're seeing that it was able to align those along the edges. Same goes for this example as well. And let's see what actually did for some of our site address points. So what I actually didn't mention earlier was that, and maybe you did notice, I created proposals for address points that I wanted to move. So I configured the rule to say, apply my proposal if there's a one-to-one relationship between my address point and the building. So we're seeing that this address point right here got moved along that proposal. Our proposal has been applied. And that's because there's a one-to-one relationship between my address points and a building. So when I had moved the site address points as well, the buildings didn't have property information in them. So when I had moved these site address points, I was able to transfer the same property information to that building as well. So now they're clearly matching. So move on to another example. So in this scenario right here, our rule got rejected. Or our proposal got rejected, I'm sorry. And that's because like I mentioned, we did want to maintain a one-to-one relationship between a site address point and a building. So over here, we're seeing one site address point to two buildings. So that move got rejected. This one got rejected as well. We're seeing two address points in the same parcel, but there's only one building. So we went ahead and said, that's not a safe move right now. So we're going to reject that. Or we had OneIntegrate reject it. All right, so let's have a look at some of the handful of rules that we have run for our or the rules that we just ran and I showed you. Let's look at a simple one. Okay, here. So here we're just checking that a road street name is not equal to to null. So because we were able to bring in, or we were able to load our data in, we were able to select exactly which feature class we wanted to work with. In the same manner, we were able to bring in that schema that's related to those feature layers. So again, that definitely adds on to us not having to hard code anything. We are just pulling this all from the context of the data that we brought in. I also want to check one of these inner feature checks. So here, all I'm saying is that an address point should be contained within exactly one parcel. And if it is contained within that parcel, I want to make sure that my property address information all match up. So we did notice that these address point attributes here were all being stored in all caps. So to make a compatible comparison, we did an on-the-fly conversion of the parcel's property address using what we call a built-in function. So a built-in function is a value that's calculated from one or more value node parameters. So we have built-ins here for geometries as well. I'm just going to breeze right through here. We can create buffers. We also use this to look at the start and end of a road. Going to keep scrolling down here. As you can see, we were also able to convert. There are mathematical functions in there as well, and it can also handle string built-in functions. So if you recall earlier where we encountered a non-conformance because the street name was Willowbrook Court that didn't match Willow Space Brook Court, we can definitely reconfigure that rule to use the built-in function for calculating this Jarrow-Winkler similarity and say that, well, if the score is high enough or those strings are close enough to match, let's go ahead and consider them a match and not have those flagged as a non-conformance. So at this point, we have been able to identify quality issues in our data through data validation. We reported those issues out, and we've automated the fixes from some of those issues. And some of you might already be thinking, well, I don't want everybody writing different versions of the same business rule. What if I only want to have a small team focus on configuring these rules in one integrate? What if I only have, or I want to explore some additional options for other members of my organization who will largely only be running these rules as opposed to actually writing them? So I want to introduce you to another product in our One Spatial suite, which is the Data Gateway. Data Gateway offers an online validation engine that gives a data provider instant feedback within the user interface itself. It utilizes the exact same integration data enhancement capabilities that we just saw on the One Integrate product. The state of Maryland actually currently hosts the Data Gateway environment on their One Integrate server. So to help facilitate their users in getting their data 911 ready, we reconfigured 911 validation rules in their One Integrate so that all their users would have to do within Data Gateway is upload their data, run their data against those rules, and download those results. I have a sample of Harford County here. So we have our site structure address points, our road center lines, and the county that contains everything else in there. So I actually want to walk through what Hartford County would have to do to validate their data using the data gateway that's currently hosted at the state of Maryland. So first thing I'm going to do is log into Data Gateway. And I'm going to simply drag my input data in here, my Harford County data. Excuse me. So what's important to note here is because these are NENA 911 rules, they were written for the NENA 911 schema. So we do have to make sure that the data here is compatible before uploading it. We can easily check if the data has been uploaded correctly using the cache map view later. I don't want to touch it yet. Give me one second. Oh, here we go. You can easily check if our data has uploaded correctly using the cache map view. And then what we're going to do is simply hit run to start the validation process. The way that I like to think about Data Gateway is an alternative solution to the old practice of data providers or the end users, sharing their data via FTP or email to a quality assurance team, and then the quality assurance team runs analytics against it, they identify any of the issues, and then push back to the data provider. There's nothing wrong with that methodology, but sometimes the data providers do find themselves playing catch up because, in reality, there's continuous editing on the data provider level. So by the time QC or QA pushes back those issues to the data provider, more often than not, we observe a mismatch or inconsistency in results. So by using Data Gateway, data providers receive instant feedback on their data, very similar to what we're just. So the feedback or these results are reported out by the engine through an issues layer, which is automatically created in the interface. It's very similar to the markups that I just showed you earlier. It pinpoints exactly where these issues occur. So from here, I can download my results. And I can also do a cached view of the result data. So again, very similar capabilities as you just saw earlier. I'm just going to show you one to be real quick about it. We were able to spot the spike on this geometry right here. So again, very similar. I'm not going to go through each one of them. Okay. So also, I want to make sure. Sorry. Okay. So Data Gateway also has a helpful tool here that we have on a dashboard, which displays our reporting widgets, and we can see how our data improves over time. For the state of Maryland, for example, they're able to track how each of their counties submitted data improves over time. So they can look at statistics based on total pass or fail per rule, really metrics that can help the state spot some trends. So if it looks like all the counties submitted road center lines are all failing the same rules, it can trigger the state to say, hey, it looks like maybe the rule has a bug, or there needs to be tweaking, or there's an inconsistency with the way that everyone is with the way everyone's schema is laid out. So through Data Gateway, we've uploaded our data, we've run our rules, reported the issues, and addressed these issues. When you're at a point when your data has reached a clean state, you can also use Data Gateway to push the data into your organization's spatial data infrastructure. Again, leveraging that same rules-based approach that we saw in OneIntegrate. For my last part of my demo, I am going to show another method of facilitating data rollup, which is through implementing a change detection process. So I'm sure everyone in attendance here has, to one capacity or another, have had to integrate multiple data sets from multiple sources collected to fit different purposes. So we even observe this when data is being turned over from city to county to state to country. And like we've tackled earlier, integrating data sets could entail schema incompatibilities. For this demo, though, I would like to focus more on the representation mismatches, be it from position issues, projection issues, or whichever data set is more current than the other. And I realize that my use cases so far have been transportation-centric, so I do want to throw it out there that you can definitely build these rules outside of that context. You can configure your business rules to fit other points, line, and polygon assets, such as the NHD data set, for example, where you're dealing with flow lines and water bodies. So over here to the right, I have an example of what we'll call the source data from the state. So a county might submit their vintage of that data to the state. And then when we overlay these two data sets, we're seeing most of this network is pretty much the same, except for the small area right here that appears to have been added. So instead of inefficiently replacing the entire network and potentially lose any associated metadata with it, we want to focus on just updating the changes. So what we're going to do is use OneIntegrate to automate the process of identifying and updating only what has changed in the data through our change detection processes. Our next use case is how we went about applying this change detection process between a sample route data from Maryland State Highway Administration, which is an LRS-based network, against a locally maintained road network. So ideally, the workflow would go like this: from loading in the input data, running our change detection processes, create proposals for how we would like to automate applying those changes, and then ultimately applying those proposals. However, there are modeling issues between these two networks, as you're probably already predicting. So some pre-processing had to be done before we had to push them through, or we could push them through our change detection. So being that our orange state routes are LRS-based, when we are comparing them to locally maintained road networks, these routes aren't broken out at intersections. Oh, I already have it. I'm sorry. Okay. So just to make that clear, so one of the challenges that we want to be able to fix or match up to properly with these representation mismatches, we are looking at this single route that would have to be matched to multiple road segments that have been broken out. And if we pan through more of these, we're seeing how there are very subtle differences between these two road networks. So, in some cases, they're subtle enough that they don't actually warrant an update. So you want to make sure to take into consideration how well these two road networks already are. And again, just focus on what actually changed. Switching gears back to my one integrate here. Okay, so we're going to determine the type of interaction between those two road networks that we just saw. So we're taking into consideration discrepancies in geometry using buffer tolerances, and also differences in bearing, some attribution as well. And then from there, we are going to create proposals. So if the changes are within tolerance of, if there are no changes at all, we're going to go ahead and create match proposals. If there's a slight change in the geometry, we're going to create reshape proposals. If a road's not there anymore, we're going to delete them. If it wasn't there before, we want to add them. And then to maintain a road network connectivity, when we eventually apply these proposals, we have an added action here to do just that, maintain that connection. So let's go ahead and look at some of the results that we have from here. So let's go through the simple ones first. Here we're seeing a simple add proposal. If I turn this off, if I turn my proposals off, we're seeing that this road has a proposal to be added. Over here, we want to delete that segment of the route that we're not seeing anymore on the road, so we have a delete proposal. And here we have a simple reshape. We're seeing a reshape proposal here because this segment here extends out to these two other roads that needed to be added or has an add proposal on them. So again, because we do want to make sure that we don't lose the network connectivity between these two networks, we want to apply these updates as intact as possible. So a distinct difference in the way some of these intersections are handled between the two networks is that this county in particular has its data set built for 911, and that particular dispatch system requires the use of pinch points for this particular case. So this is where a pre-processing to change detection would have to take place. So in one integrate, we actually had to handle these pinch points by essentially untying the twist tie in here to make to properly match the state route network as close as possible to the road network. So by temporarily I'm going to turn this off real quick. By temporarily modifying a road to where pinch points occur, we're able to compare the two networks now on an even playing field. And in doing so, instead of producing a messy, inaccurate mix of proposals, we're now closely able to mirror the orange road network and see that these two are actually matches. One of a few more examples right here. After untying the twist ties of this three-way pinch point, we're now seeing match proposals. And same goes for our hashtag intersection. We're seeing here that one integrate was successfully able to handle these as well. Okay, so using our business rules we configured using one integrate, we were able to validate our data. We integrated multiple data sets from different sources as well. Where schemas weren't matching, we standardized them. Where there were differences in data modeling, we were able to modify them. Where we found quality issues, not only did we report them out, but we also automated their fix-ups and produced enhanced data. So with the variety of use cases that I hope I was able to convey to you today, I also hope that everyone's feeling optimistic about their own data, no matter what stage in their life cycle they're in. So we definitely look forward to expanding one integrate's use cases. And with that, Chad, are there any questions on our chat window?
Hey, yes, that was great. Thank you. We have a few, and feel free to keep them coming in. We have a couple minutes here, so send them on over. But to start off, can we commit changes to an Esri geodatabase?
Yes, absolutely. So with the One Integrate Enterprise that we saw earlier, we're able to stick, for example, if we were to do the same change detection processes, but through the bringing in those two road networks into One Integrate, we are able to commit the changes directly and not have to go through any of the proposal stages anymore. So we can definitely that definitely would produce a more cohesive data set, because then we're only committing the changes that are that we're seeing with the network, as opposed to having to create that proposal and rejecting the proposal and so on and so forth.
Perfect.
Hope that answered that question.
I believe so. Can we take some of the existing rules and update them to meet our business needs?
Yes, absolutely. So maybe I should go back to One Integrate for this one. As you can see, I didn't have to hard code any of my rules here. Like bringing in just all of the available information that we already have in our data, we're able to set it up in such a way that we're using exactly the same compatible rules to our available data that we're bringing in. If you wanted to reuse these, we can definitely export these out. And like you saw in the data gateway, it's another way of sharing these rules within an organization.
Perfect. And you actually just hit on the next one, was can you share rules?
Oh, yeah. So sorry, I didn't mean to. So yes, definitely you can share these rules. You can, there's an option here to definitely download these and upload these. That way, you can only be sharing, or this, I guess this ensures that we're only using the same version. I think that's what we're trying to get around here, is that just to make sure that everybody running these rules are using the same version of a rule set. So you can definitely do that.
All right, let's see here, a couple more. Can you report on which features were edited?
Yes, so within the interface itself, actually, you do have an option here to check out your results and actually view some of the reported non-conformances and all the objects in there. So apart from me creating these markups, or in the data gateway side, receiving those automatically created issues layer, we're able to report out exactly which data the non-conformance is being seen in, and also report how many of these features in that, how many of the objects in that feature class failed the rule.
All right, couple more here. Can the proposals be saved for the next run in case they weren't accepted?
Yeah, so there's definitely a way to make that pre-process before actually applying. So as you can see here, I did go directly to applying my proposals, but as a you can definitely configure a rule to say, if it was rejected, go ahead and move it. Or if it was rejected, do not touch it. If it was applied, then go ahead and apply it. So there's a pre-process in there that you can definitely do, so that you can do it in one session as opposed to having to take them out.
All right.
Did I answer that question?
I think so. One other question we have here, is the build topology process the only way to align features?
Definitely not. There are other ways, similar to how you saw how I used moving my building points or my address points to my building, where I created that almost like a shift vector between that site address point and the building area. So what I can do is, when you're trying to align boundary edges to, for example, road networks, I can use the existing vertices on that boundary to snap them to the closest parts of my roads that are within a tolerance, of course. So by using shift vectors like that, we can definitely map it down to, or map up and down to where we want those features to align. And actually, we've done very similar thing with NOAA, where we've had to edge match between two charts of different, of varying scales.
Okay, and here just came in another one here. Are there rules for change detection of attributes?
Yeah, so part of the part of the determine interaction here, I know I only mostly highlighted using buffer tolerances or geometry, and I also mentioned using differences in bearing when we're trying to create that match. I had actually also put in there that certain attributes such as my street names have to match, because obviously we don't want to be adding two conflicting attributes and creating a match out of those without trying to take into consideration the non-spatial factors that we have to take into consideration for those road networks.
All right. Well, I think that's what the questions we have for now, but if anybody has any more, feel free to reach out anytime to myself or Melissa, and we can answer those and get those back to you. Again, we'll post this up on the site, so we'll get that around to everybody so you can share it with your teams. And looks like we'll end a little bit early, so give you a few minutes back on your day. But thanks a lot for the time. I hope you found this exciting, and we look forward to talking.
Thank you very much.
Take care. Bye.